Free fall is the motion of an object where the only force acting is gravity. Alright, so that is 3.1. Let's go ahead and do 3.2.1. So the question is saying that let's calculate the time taken for ball A to strike the ground. So let's look at ball A here. It is released from a height of 15.2 meters above the ground. When it is released, we know fully well that VI is equals to 0 meters per second. Right, and we have delta Y. So let's take up as positive. If we take up as positive, then delta Y should be equals to minus 15.2 meters when our object strikes the ground. Another information we have is the acceleration, as we always do, minus 9.8 meters per second squared. And what are we looking for? We're looking for the time it takes the ball to strike the ground. Right, so based on the variables we have, VI, acceleration, delta Y, and the time that we're looking for, it's easy to see now that we're going to say delta Y is equals to VI delta T plus a half A delta T squared. Right, initially I didn't want to use this formula because what about delta T squared and delta T? I'm going to have to solve this by factorizing, right? But then I realized that VI is equals to 0. So this term here is going to give me 0. I'm not going to have so many issues, right? So if we go ahead and substitute, we're going to get minus 15.2 is equals to VI, which is 0, right? Multiplied by the time. So that term falls away. Plus a half. The acceleration is minus 9.8 and the time is what we're looking for. So we're going to have minus 15.82 being equals to, this term falls away. We just have minus 4.9 delta T squared. So it's easy to see now that delta T will be equals to the square root of 15.2 divided by 4.9. Right, so now it's just a matter of putting that in your calculator, and what am I getting? I'm getting 1.76126 seconds. So that is the time it takes ball A to strike the ground. Right, it makes sense because it's gonna take about 1 second to cover 9.8 meters, right? And then the rest of the height can take less than a second, right? Let's do 3.2.2. So in 3.2.2, quite demanding one, right? 5 marks. We're looking for the magnitude of the velocity with which ball B was projected from the ground. So let's look at the information we have. We don't have VI. If you take the motion from the time it was projected to the maximum height, you can say you have a VF, which is equals to 0, right? But we don't know the maximum height also, because at this point, what we have is the initial velocity, which is unknown, and the acceleration, which is minus 9.8 meters per second squared. And then another thing we can calculate is the time for the motion of ball B, right? Because we are told that ball A and ball B, they strike the ground at the same time. But then when ball A was at this point, that is only when ball B was projected upwards. So we can say that the total time of ball A minus the time taken by ball A to go from maximum height to 3.2 meters below the maximum height will give us the time for ball B. Right, so let's go ahead and do that. So for ball B, not ball B but ball A, we can say that delta y is equals to vi delta t plus a half a delta t squared. Right, so now our delta y, we can say that is minus 3.2 meters because we're looking for the time taken for only this journey. That is the time we're interested in, right? We're going to subtract it from the total time, and that will be the time for ball B. All right, so if we substitute minus 3.2, then our vi 0 delta t plus a half minus 9.8 delta t squared. Right, so we're going to have minus 3.2 being equals to minus 4.9 delta t squared. If we make delta t the subject of the formula, we're going to get 3.2 divided by 4.9. We know that minus and minus, they're going to cancel out, right? And our time will be 0.8. So we have 0.8081. So right, the time for this part of the motion from this point to this point is 0.8081. Right, so to find the time for the entire motion of ball B, we can say that so the time for ball B, we're going to say that it is equals to the total time for ball A, which is 1.76126 minus 0.8081. Right, so let me just put that in my calculator real quick so that I can see what I get. I'm getting 0.95316 seconds. Right, so that is the total time for ball B. Let's revisit the information we have for ball B and see if we can manage to find that VI. We have the time for the total motion, right? We can put that in mind. And then VI is still our unknown. We have the acceleration, which is minus 9.8 meters per second squared. But if we take the motion from the ground to the maximum height, we can say that we have VF, right? We have a VF which is equals to 0. And then to find the change in time from ground to 0, we're going to say total time divided by 2, because the time taken from ground to the maximum height shall be the same time from maximum height to the ground. It is actually wrong for me to put this dot here. We don't know how high ball B is above the ground at maximum height, right? So if we divide that total time by 2, so we have 0.95316 divided by 2. Let me just put that in my calculator real quick. I'm getting 0.4765. So now I have delta t. I have delta t. I have vi. Vi is what I'm looking for. I have acceleration. I have vf. So it's easy to see now that I can say vf is equals to vi plus a delta t. Vf is 0. Vi is what we're interested in, plus our acceleration, which is minus 9.8 multiplied by the time, which is 0.47658. So minus Vi is going to be equals to, so I have minus 9.8 multiplied by 0.47658. Right, so I get minus Vi being equals to minus 4.6705, and then Vi is equals to 4.6705 meters per second. Right, that is the initial velocity for which ball B is projected upwards. Now the last question, 3.3. So on the same system of axes, let's draw the position time graphs to show the motions of both ball A and B from the instant ball A is dropped until the time it reaches the ground. Let's take the ground as the 0 position, right? Because usually they will say let's take the ground as our reference point, and that will lead to a lot of ambiguity. What do they mean? You know, reference point. Are we taking it as 0? Are we what is happening. But then when they say, we must take it as the 0 position, that is clear. There is no ambiguity. You know exactly what is expected of you. Right, so the x-axis, there we go. And then obviously on the x-axis we're gonna have the time in seconds, and on the y-axis we're gonna have delta y in meters. Maximum height 15.2. So let's start with ball A, right? So ball A is starting from 15.2, and then it goes down until it strikes the ground, right? It takes 1.76 seconds for that motion. So we have 1.76 seconds, right? And then now we have to go to ball B. So ball B is only projected 0.8 seconds later. So we have 0.8 here, right? Yeah, that is the time at which is projected. And then it goes up to its maximum height, which is less than that of ball A. That's, yeah, it's easy to see. But then they strike the ground at the same time. So I think we should have something like this. I wonder what you guys did. Can you please let me know in the comments if we have the same position time graph?